Good day, everyone. My name is JULIENNE from Psalm 11, and today we're going to talk about the measures of central tendency of ungrouped data. Before we begin, what are the measures of central tendency of ungrouped data? So the measures of central tendency are the summary measure that describes a whole set of data with a single quantity that is representing the middle or center of its distribution, the way of which group of data that cluster around the central value. In short, these are the measures that tell us where the center of a data set is located. The most commonly used measures of central tendency are the mean, median, and the mode. What is the meaning of mean? The mean is the most commonly used measure of central tendency. When we speak of average, we always refer to the mean. We can use the formula of summation of x over n. For example, 5 friends in English class of 30 students received test grades of 75, 79, 82, 87, and 90. Find the mean of these test scores. So using our formula, summation of x over n, we're going to add up all the test grades. And since we only have 5 means, we're going to use 5 as our n. So adding all the test scores, we're going to have 413 over 5. And we're just going to divide it, and we're going to have x is equals to 82.6. And now we're going to talk about median. So what is median? Median is the midpoint of the data array. Before finding this value, the data must be arranged in order, from least to greatest or vice versa. The median will either be a specific value or will fall between two values. For example, is the x1, x2, x3, x4, and x5. x3 being in the middle will be our median. As for the second example shown, x1, x2, x3, x4, x5, and x6, we have two medians since we have 6. So what we're going to do is that we're going to add up both x3 and x4, then we're going to divide it into 2, and we're going to get our median. For the first example, it says that 7 mothers were selected and given a blood pressure check. Their blood pressure were recorded below: 120, 110, 115, 130, 125, 123, and 114. So to find their median, we need to arrange the data in order. So in this case, I did least to greatest. So 110, 114, 115, 120, 123, 125, and 130. And since 120 is in the middle, that will be our midpoint, which is that x is equals to 120. For the second example, 8 novels were randomly selected and the numbers of pages were recorded as follows: 419, 528, 505, 425, 309, 328, 625, and 250. So to find their median, we need to arrange the data in order. Like what I did with the first example, I arranged the data from the least to the greatest: 250, 309, 328, 419, 425, 505, 528, and 625. Since we have two midpoints, we're going to add both 419 and 425, which equals to 844, and we're going to divide it into 2, and our midpoint will be at 422. After the mean and the median, we're now going to move into mode. So what is mode? Mode is the value that occurs most often in the data set. It is the number, value, observation in the data set which appears the most number of times. For the first example, we need to find the mode of the given data set. So if you would see, we have a lot of numbers right now on the screen. Second thing we need to do is to arrange the data set in ascending or descending order, just like the median. In this case, I did ascending, so I started from 3 up to 35. In the given data, the number that appeared the most of times is number 5, and this is also known as the unimodal. Unimodal data set is if we only have one number that is appeared most of the times. In this case, we have number 5. For the second example, the speed of 12 stenographers in typing per minute are as follows: 114, 131, 114, 123, 119, 105, 145, 115, 134, 120, 123, and 112. Second thing you need to do is to arrange it from ascending or descending order. In this case, I did it with ascending order. Thus, the data set has two modes, which is 114 and 123, since both are the most repeated numbers. The data set is said to be bimodal. What does bimodal means? Bimodal means if you have two modes in your given data set. For the third example, we have 5, 6, 9, 11, 3, 6, 4, and 25 as our given data set. If you would notice, there's no repeated numbers in there. Thus, there is no mode. The next one will be the weighted mean. The weighted mean of the n numbers x1, x2, and x3, also known as xn, with the respective assigned weights w1, w2, w3, or wn. We usually use this when we're computing our grades, especially in college since we have units per subject. So the formula will be summation of x times w over summation of w, where summation of x times w is the sum of the products formed by multiplying each number by its assigned weight, and summation of w is the sum of all weights. For example, many colleges use the 4.0 grading system, where A is 4, B is 3, C is 2, and D is 1. Also F as 0. Find the grade point average of Denver's grades in the given semester course grade. So we have our formula there, the summation of x times w over summation of w. We're gonna substitute the x as the grades and the w as the units. Thus we got 3 times 4 plus 4 times 3 plus 1 times 3 plus 2 times 4 over 14. Where did we get the 14? Denver has 14 units in the semester. So we're going to add everything up, and it will be equals to 35 over 14, and we just divide it, and we're going to get 2.5. So Denver's GPA for the given semester is 2.5. Lastly, we're going to talk about the frequency distribution. It is a table that lists observed events and the frequency occurrence of each observed event. It is often used to organize the raw data. For example, you would see on your left side corner are the number of computers per household, while on your right side corner, you're going to see a table, which means the number of computers are substituted as X and the number of households is substitute of F, in which our N will be 40 since there will be 40 total of households. The formula that we're going to use for this one will be the mean formula, which is the summation of f of x over n. So we're going to substitute the number of computers into x, and then we're going to multiply it into the number of households, which will be the f. So we will have 0 times 5 plus 1 times 12 plus 2 times 14 plus 3 times 3 plus 4 times 2 plus 5 times 3 plus 6 times 0 plus 7 times 1, and we're going to add all of them up and divide them to 40 because there's 40 people, the number of households. So it will be equal to 79 over 40, and we're just going to divide it, and the mean of computers per household will be 2.